Hello everyone. So today we'll discuss about hydrogen, its importance as an alternate energy source, and what is the meaning of the term green, blue, gray hydrogen, which you often see in the discussion. So we'll have the basic understanding of hydrogen as an energy carrier, the meaning behind its various names, the production process in brief that determines whether hydrogen will be dubbed green, blue, gray, pink, etc. Feature of hydrogen as an alternate fuel source, and what all these have to do in fighting the climate crisis. So we'll first see what is hydrogen energy. So a lot of people believe that hydrogen will be the next big thing when it comes to energy. And this is because unlike petrol or gas, hydrogen does not release any harmful carbon into the environment. And the only byproduct when we burn hydrogen will be water because hydrogen will combine with oxygen in the atmosphere, producing water as a byproduct. But is it really so simple? In this video, we'll see about it. Going forward, we'll first discuss the terminology like blue hydrogen, green hydrogen, etc. So we'll see what is blue hydrogen is meant by. Blue hydrogen is produced when natural gas is split into hydrogen and carbon dioxide, either by steam methane reforming SMR or thermal reforming ATR process. So natural gas is split by these two processes, SMR or ATR, and when natural gas is split, it is split into hydrogen and carbon dioxide. This SMR and ATR you can see in detail, but what is important here is that the carbon which is produced by splitting of natural gas is captured and stored, so it is not released into the atmosphere, and this mitigates the adverse impact on our environment. And the capturing is done by CCUS process, that is called carbon capture, usage and storage process. So blue hydrogen is produced by splitting of natural gas, and when we split natural gas we get hydrogen and also carbon dioxide as a byproduct. This carbon dioxide is captured and stored, and it is not released to the atmosphere, so there is very minimal impact on the environment in production of blue hydrogen. This you can see in the flowchart. This is natural gas by SMR or ATR process. It will be split into hydrogen and carbon dioxide. This hydrogen you can use, and this carbon dioxide is captured and stored. Next, we'll see gray hydrogen. Gray hydrogen production process is also similar to the blue hydrogen. That is, natural gas is split into hydrogen and carbon dioxide either by SMR or ATR process. However, the important difference is that the carbon which will be produced is not captured and stored. It is released into the atmosphere. So again, it will increase the greenhouse gas in the atmosphere in production of this gray hydrogen. Pro, flowchart will understand it. This is natural gas by same process, SMR or ATR. It will be split into hydrogen and carbon dioxide, and this carbon dioxide is released directly into the atmosphere. Next, we'll see green hydrogen. So green hydrogen is produced by splitting of water by electrolysis. And when you do the electrolysis of water, it will produce hydrogen and oxygen, and you can use this hydrogen, and this oxygen is released into the atmosphere. So you can see that there will be no negative impact because we are not releasing any carbon while producing this green hydrogen. However, the important thing is that to produce electrolysis of water, we need power. We know that electrolysis need electricity. So production of electricity, we need power. And this power is provided by renewable energy sources such as wind or solar energy. So that makes green hydrogen the cleanest option because we are not releasing any carbon into the environment, and moreover the power we are producing by using renewable energy sources like wind or solar. It is a combination of energy. In case of green hydrogen, we can use wind energy or solar energy and without any carbon dioxide as byproduct. So next we'll discuss pink and yellow hydrogen. Similar to green hydrogen, pink and yellow hydrogens are also produced by electrolysis, but in case of pink hydrogen, the electricity required for electrolysis of water is provided by use of nuclear energy. And in case of yellow hydrogen, the power source for electricity is only solar energy. If you remember, in green hydrogen, the power source to produce electricity was a combination of wind or solar energy. However, in case of your yellow hydrogen, the power source to produce the electricity is the solar energy. So We'll summarize. Blue or gray hydrogen are produced by splitting of natural gas, and in this process, hydrogen and carbon dioxide are produced, and the carbon dioxide produced are captured and stored in case of blue hydrogen, and in case of gray hydrogen, the carbon dioxide produced is directly released into the atmosphere. Then green, pink, and yellow hydrogen, all these three types of hydrogen are produced by electrolysis of water, and to provide or to produce the electrolysis of water, we need to supply power, and when we supply power, we get hydrogen and oxygen by electrolysis of water. This hydrogen we can use, and this oxygen is directly released into the atmosphere, and these power source are different for different type of hydrogen. For green hydrogen, the power source is a combination of wind or solar energy. For pink hydrogen, the power source is nuclear energy, and for yellow hydrogen, the power source is only solar energy.